sec. 13.
13, yeah. So plus or minus 13. So there's a list of all these squares and square roots that you need to know. And I don't know where you're supposed to stop, but like 13 squared is 169. So that might be the one to stop at. I'm not sure. Okay, so we're gonna look at number 4 next. And so sometimes you got to do some algebra, some steps before you can take the square root. So in all the previous problems, the x squared was already isolated. Now it is not. You have to divide both sides by 4. So this gives you x squared equals 100. And now it's very similar to the previous problems we were doing. There's 2 answers. You take the square root of both sides. So x equals plus or minus 10. All right, so let's look at, we're going to skip 5 for now. We're going to come back to that. It's kind of an odd one. So let's look at 6. So there's kind of a related question here, which is like, let's just say it was 5x plus 3 equals 128. What would you do to solve for x? What would you undo first? Would you undo multiplication by 5 or addition by 3?
You do the addition thing first.
Yeah, you'd subtract 3 from both sides. Same thing applies to this problem. You're going to subtract 3 from both sides. That's 5x squared equals 125, like that. Okay, and then you would divide 5, both sides by 5. X squared equals 25.
So x would be 5. Or
anything else?
Negative 5.
Yes, there's always 2 solutions until otherwise stated. All right, we will go back to 5, but not yet. Let's have you look at 7. You try 7 on your own, please, and if you have questions, please ask.
Positive 6, negative 6?
Yes. All right, and 8, have you try 8?
Positive 2, negative 2?
Yes. All right. Okay, so now we're going to go back and look at I guess we'll look at 5. So just a brief bit of information here. So when you take the square root on the right, there's a square root property that you might need to know. It's that you can take the square root of the top and then the square root of the bottom separately. So this problem becomes plus or minus the square root of 25 over the square root of 36 there. So you take them separately. Okay, 5 over 6 like that. So why is that useful? We'll look at number 29. I'm sorry, 9. It's very similar to number 5. It's we got to do a little bit of work here. We're gonna have to first add 1 to both sides. And then you're going to divide both sides by 25. So just because there's a fraction, you don't want to get too overwhelmed and think that that's impossible. It does work on occasions. So you're going to take the square root of both sides. Okay, and then you end up taking the square root of both the top and the bottom. So it's 1 over 5, plus or minus.
Okay.
Any questions on that before we move on to kind of some new types of problems?
No.
Give me just 30 seconds, please. I'll be right back. All right, I'm back. So we're gonna look at number 10 here. And what's different about this one is when you subtract 7 from both sides, you get x squared equals 0.
Yeah.
Okay. Now the square root of 0 is the first one where there's not 2 answers. There's no such thing as like a positive and a negative 0. There's just a 0. Okay, so this is the only answer. So it's kind of an exception to what we've been doing.
Oh.
It's not like plus 0 minus 0. It's just 0. Right. So 11 is kind of another exception. We'll look at this one next. Okay, so we're going to add 8 to both sides. So this leaves you with x squared equals minus 1. Now you can only take the square root of a positive or 0. Is this number on the right, positive or 0?
No.
No. This has no solution for right now. Depending on what you guys do in class, you may or may not learn that there's a solution to this. Any questions on that?
No.
All right, so we're gonna skip 12 for the moment. I want you to look at 13, 14, and 15 and give me the solutions as you go. You know enough to do these. They're not super difficult, but take a look at that and let me know what you come up with.
The first one is 9, -9.
Okay, 9 and -9, good.
Yeah. The 14 is 7, -7.
Okay. About the last one.
That'd be 6, -6.
What did we just say in this previous problem right here?
Oh yeah, I forgot about that.
Yeah, the way the brain works is like you do 2 in a row, you think, oh, the third one's just like it, and it's not. It's there is no solution. There's no number that when you square, because like here's what you just told me. 6 times 6, which we know is 36, is -36, which is not true. And then same thing with 2 negatives, right? 2 negatives make a positive. That's not -36. Right, is that okay?
Yeah. Yeah.
Okay. All right, so we're going to look at 16 now together. And all right, so the difference between this problem and the previous problems is that there's like stuff inside parentheses that's squared. But what if I told you that you treat this problem like it was, and I'll just use u squared equals 49. Would you agree that you would first take the square root of both sides?
Yeah.
So we're going to do that. We're going to do the same thing over here on the left. We're going to take the square root of both sides. Now on the left, the square root undoes the square. So on the left, it just becomes x plus 5. And on the right, it becomes plus or minus 7. I've been hearing this language. Are they talking about a case 1, case 2 in class?
Yeah, they're talking about case. I don't know. I don't quite remember which one.
Yeah, and I don't know why they're doing this. It just becomes 2 equations. It's x plus 5 equals the positive number, x plus 5 equals the negative number. They're both true. They're both you have to solve both of them. Okay, and that means you're not quite done. You got to subtract 5 from both sides. Subtract 5 from both sides. So x equals 2, x equals minus 12.
All right.
All right, so for just to revisit this problem again, just to go through it, like you don't do anything. You don't like expand this on the left. You end up taking the square root left and right. There's 2 numbers, plus or minus. You do each of them, +7, -7, and you solve here. So if you understood that, I'd like you to try 17 on your own.
All right.
If you have questions, please ask.
All right, x equals 8 and x equals minus 22.
Okay, and those are correct. Let me tell you how I'm checking those. 8 plus 7 squared, so is 15 squared 225? Yes, that works out. And then minus 22 plus 7 is minus 15 squared, which is 225. Very good. Okay. All right. So I think there's one more like that. Yeah, 18 is like that. So after 18, we move to kind of a new grouping of questions. But for 18, I think you can see that it's kind of like the last one. You got to add 6 to both sides. So you get x minus 8 squared equals 36. Okay. And from here, you're going to take a square root of both sides. So would you mind solving it from here for us, letting me know what you come up with?
Sure. X equals 12 and x equals 0.
You're close. I think I'm not sure what happened here, so we'll look at it together. So did you get x minus 8 equals 6, x minus 8 equals minus 6?
Oh yeah, I did. Why did I wrote it as 6? I don't know why I did that.
Oh, you put x minus 6 equals 6? Okay, that would do it. Yeah, so here you can see that when you add 8, you get 14. Add 8, you get positive 2.
Oops.
Yeah, that's okay. I mean, we're practicing. It's kind of like if you play sports or played sports, you're practicing for the big game. Um, all right, so we're going to go back to number 12 now. And this one's a little bit different, but it leads us into the other problems. So let's take a look at number 12. So I'm gonna add x squared to both sides. And then I'm gonna rewrite it so the x squared is on the left. But it's x squared equals 30. And this is problematic because we know that 5 squared is 25 and 6 squared is 36, but we do not know the square root of 30. And actually, this one does not reduce. You would normally try prime factorization of this, but do you see that there's no pairs, no duplicates?
Yeah.
So this is your answer right here. But what I want to ask you or remind you about is this part down here, the prime factorization. Is that something that you remember?
Yeah.
A little bit. Okay. So we're going to move to 19. And 19 here has elements of everything we've been doing. So it's, it's a good synthesis question. Your goal is to isolate the x minus 4 squared. Okay, so that means you've got to add 10 to both sides of the equation. So x minus 4 squared equals 20. Do you see that? You're just isolating it. Now you're going to take the square root of both sides. Okay, so we've been doing this a bunch. Square root of the left plus or minus the square root of the right. Now on the left, it is x minus 4 equals. On the right, though, you have to reduce the square root of 20. So this is where you got to make that prime factorization. 2 and 10, 2 and 5. This time, there are a pair of 2's. So it's plus or minus 2 square root 5. So if you recall, the pair comes out, one of the numbers comes out when you have a pair, and the other number stays inside. I apologize. I don't remember if we've done this or not. Sometimes the lessons blend together. I think we did this last time. Yeah. Good. Now, we're not done, even though we've done a bunch. We're not done, though. You have to add 4 to both sides. Now, I will sneak it up in front here. So with the answer, it looks like this: 4 plus or minus 2 square root 5. Now, what you cannot do is you can't combine anything here. Like the 2 is attached to the square root of 5. The 4 is off, to the left here. So it's not like you can add these together. They're separate entities. Bacon and eggs, if you will. If you would like a different analogy, we can make one. I can make one up for that. But it doesn't look right, but this is your answer.
Okay.
Any questions on that before we do another one?
No.
Okay, this one's a lot like the previous one. We're gonna undo the number that's this here, the plus 10. So you're gonna subtract 10 from both sides. So that's x plus 3 squared equals 8. And then we're going to take a square root of both sides. So on the left, it's x plus 3. On the right, you have to come over here and figure out the square root of 8. So would you attempt to figure that out for us, please?
Sure. Two times square root of 2.
Good. So it's plus or minus 2 square root 2. And then from here, you're going to subtract 3 from both sides. Again, it's better to put that in the front. It reads better. It avoids other errors. But these are your two solutions.
All right.
Okay. All right, so go ahead and try this one on your own, please. And hopefully, based on the examples we've done, it's pretty straightforward.
I'm stuck at the square root of 5. I forgot how to do it when it's a prime number.
You just leave it. It just stays the square root of 5.
Okay.
Yeah.
All right.
Good question though. Do you have a final answer for me?
Yeah, x equals -4 plus or minus the square root of 5.
All right, really good. Really, really good. Did we do all of them on this page? Just to confirm. I think we did, but
Yeah.
okay. So one thing we could do here in this post review is we could just talk about the type that each one is.
Yeah.
And I mean, we can do some. We obviously can't do them all, I don't think, but knowing the type might be good, and then you could decide if you want us to do it, work it out. So as a reminder here, greatest common factor, and some of them could have more than one, by the way. Difference of squares, perfect square trinomial, a equals 1, and then the last one we did was a not equal to 1, which was a grouping problem. So what do you see here on the left?
On the left. They don't have a greatest common factor.
Okay, I agree, that one's out. They do not. The difference of squares should be jumping out at you because it's got two terms. Two terms. Okay. So this is a difference of squares. Do you want us to do this one?
Yeah.
Okay. So you have to figure out what's squared minus what's squared gets you back to the previous line. Basically, how do you get 81 from a number? How do you get x squared from something down here?
9 and
X.
Yeah, 9 and 4.
And then 4 y. Okay, so then the formula here, I'll write that in blue. The formula is a squared minus b squared becomes a minus b, a plus b, and you want to think of a and b as being what's in parentheses. So what would the result be of factoring this? Can you tell me?
Let me see.
What is a? I'm basically asking what is a in this problem? What is b in this problem?
Oh, a is 9 and
X, 9x.
b, yeah, 9x.
And b is?
Yeah, b is 4y.
Okay, so hopefully you got 9x minus 4y, 9x plus 4y.
Okay. I see what I'm supposed to be doing.
All right, so let's look at number 2. So same list. Kind of go through that list and see if one or something stands out to you.
Is it I think it's either A equals 1.
Yes, I would put this at an A equals 1. So you're trying to find two numbers that multiply to 12 but add up to 13.
One and 12.
Yes. Yes, this becomes x plus 1, x plus 12, or you can switch the order.
All right.
Any questions on that?
No, it was pretty
Yeah,
straightforward.
that one's good. That one's good. Okay, let me bring the list down here so we can have it while we're looking at this question here. Oh boy, come on. Okay, so go through this list, see what you think. See if there's one that stands out to you.
Is it also A equals 1?
This one is an A equals 1, but it's better as a 3. Okay, so you can take the square root of the first and the square root of the last. Do you know the square root of 289 offhand?
I do not.
So it's 17. And then when you squeeze those together and double it, do you get 34x? Yes. So this one is a perfect square trinomial. You know, I mean, we haven't covered this a lot, but its form is, we'll do that in blue here, is a squared plus 2ab plus b squared, and this becomes a plus b squared. So in your problem, the b is 17 because 17 squared gets you back to 289. Your a is x squared gets you back to a there. So it's x plus 17 squared like that.
Okay.
It is an a equals 1. You would just have to recognize that it's 17 twice. And then you would maybe wonder, well, why didn't I recognize that it was a perfect square trinomial? Maybe, you know.
Yeah.
Sorry, Dad, let me know when you get all that down. We'll go to the next one.
I got it.
Okay. Let's go to the next one here. same question as always, what type is this?
Um, could be GCF.
What would the GCF be? What goes into all three? Has to go into all three.
Uh, yeah, I forgot about
So there's no
the
GCF.
x squared.
Yeah, no GCF on this one. It's not a difference of squares because there's three terms.
Yeah.
Can you take the square root of 24?
Yes.
Perfectly. Like, is it a
I
nice
think.
number? Friendly?
Oh yeah.
It is
It's
not. So this is an a equals 1.
uh,
All right, so you want to find two numbers that multiply to negative 24, but then add to negative 10.
all right. Be 4 or negative 4 and 6, and or negative 4 and negative 6.
So those do not multiply. They multiply
Oh
to
yeah.
positive 24. So yeah, this one's tough. I mean, it's sometimes you got to make the whole list here, and it's time consuming. But you will see that like these work right here.
Yeah.
Okay, so that becomes x plus 2, x minus 12.
All right.
Okay, so number 5 here. Grab this list of things here. All right, take a look. Let me know what stands out to you.
All right. I think it is GCF.
It is a GCF. Yes. Well, now what is the GCF? That's the more important question.
5.
Yeah, so we got 5, but there's a little more, tiny bit more.
Oh yeah, 5x.
5x. All right, so in parentheses here, you're going to get x squared plus 6x plus 8. I mentioned this earlier. It could be more than one. So this one is another. This one's another one of these on the list.
Okay.
So this is an A equals 1 also. So you have to keep going. Can't stop until you're totally done.
Okay, so that'd be dang it, I forgot what to do from here.
Two numbers that multiply to 8 but add up to 6.
Oh, okay, it's the last two. All right.
Yes.
Two and four.
Yes. Got it. All right. Well, that's going to do it for us for today.